Okay, now Assalamu alaikum. Continuing from the same point where we had left earlier, we were talking about the class A, B, C network, and let's recap what were we doing. Class A 0.0.0.0 to 127.255.255.255. Class B is 128.0.0.0 to 191.255.255.255. Then C is 192.0.0.0 to 223.255.255.255. Now, how to remember? Like I'm sitting in the examination, I may forget. Giving you a tip, you simply remember the values beginning 0, 128, and 192. Like you remember 0, 128, 192. And then you will never make a mistake at all in remembering the classes because a question can come in the paper. It has come in the paper asking you that which class does it belong to, or they're asking about the net ID and the host ID. So for that, we are moving to a discussion. Be very attentive. If you have a question, you may ask. Please stop me immediately the moment there is some confusion. Now they have given you an example of a class C, and they have talked about with a different color coding. Here, since it is a class C, it means that the first three values are fixed for every connected computer. Be clear. Every computer in the network of class C will have the first three values to be same, and the last value is going to denote the host, or you can say the my computer. My computer will have, if I'm a part of the class C network, my host ID will be same for with my colleagues. But my net ID will be same as my colleague's one, and the host ID will be different. Like I may have 240, my colleague has 241, another one will have 241, 242. In this manner, the host IDs will be changing, and there is going to be denoting the personal. The way we talk about, just an example, okay, 240 is mine, 241 is some other, 242 is some others, and that is a smaller network. When you talk about definitely the bifurcation is going to be in the binary form, because binary is something which is understood by the computer. Computer only understands the binary value, no other value it understands. So this is what is written by the network administrator, and this is what we humans comprehend, and this is what the computer understands. This is the main thing. When you talk about the bifurcation, the host ID will be only 240, as I said, and the net ID will be 190.15.25, which will be the same for everyone. Now let me make it 192. Okay, fine. So this is something that you should be very clear about, that this is denoting the host ID and the net ID. Just make the shortcut. NH. N is network ID and H is the host ID. So then you will remember clearly that network ID comes first and host ID comes later. Now, another example is your example of class B network. And you can see class B starts with 128. So 128.148.12.14. So you can see for yourself here the color coding is helpful, but in the examination there will be no color coding. You need to remember 0, 128, 192 to remember classes A, B, C. And class B has the first 16 bits as the net ID and the last 16 bits as the host ID. This is your class B network. And last, it's the class A network. As you can see here, the first value, the first binary value is going to be your net ID, and the host ID will be 68.0.43, here shown with a different color. But you need to remember class A has only the first byte or the first 8 bits as a fixed one for all the connected computers, and the rest of the bits are going to be the host IDs. Are you clear? Are you clear about this? Then making it further, you're talking about the subnet. And what is subnet? Sub means what? Sub means apart. So this was my host ID. Now moving to subnet ID will be 68.0, and here the host ID will be 43 only. This is something that you need to know for, again, 129 is the net ID. I mean, that is very clear. Out of the 68.0.43 was the host ID. That was also clear. Now we're talking about the concept of subnetting. Subnetting means further bifurcating. Like, just giving an example, if I say different cities or different schools, just to make you understand, I'm giving an example right now. The school may be any big network. The big network of school is spread over different cities. So then we say the school name, then we say the region, then we say the place, and then we say the main place. Okay, for example, I can just give any example of a very big school network. That big school network's name, then its region, maybe southern region or northern region whichever region they're talking about, then its city where they belong to, and then lastly it will be the place where where that school is. In this manner, you can very easily understand the concept. Now, the subnetting means that we are dividing it further, and this division is done in this manner, that subnet ID will be 68.0 and host ID will be only 43. In this manner, this will be your actual host ID in case of subnetting being done. Any questions? G, if a question, this is the question that is coming in our paper. So just be clear about the concept of subnetting. Sub means again dividing into further different parts. May I move ahead? Now, again, this is only, now you can see for yourself, it becomes clear that IPv4 system has, okay, it soon become clear that that IPv4 system provides insufficient addresses range. That is what we talked about right now. For example, a user with a medium-sized Class B network might have only 284 host machines, and the Class B license allows them for 65534 machines, means that that will be not able to be accessed properly. And okay, now benefits of subnetting. Benefits of subnetting is simply making the number of computers available. For example, if without the okay, Anne has raised a question about the benefits of subnetting. So you can see the subnetting is simply done to increase the range of the computers. So we are going to talk about this CIDR also right now here. Without subnetting, what is the disadvantage? That you may not have the a large number of computers available, but with subnetting, you can have more computers available because of the division. That is what the advantage of subnetting is. Now, this is just a discussion that telling you that if you are talking about the licenses are there for many, but with this, what is happening? And another important concept of this is CIDR, classless interdomain routing. And the problem that we were facing about the IPv4 systems are reduced to a certain extent by using CIDR, classless interdomain routing. And how is it being done? A suffix is used, and a suffix is used such as 192. Now, looking at 192, what strikes your mind? Which class is it belonging to? G children, 192. I said now that looking at the first, we decide the class. So looking at 192, which class does it belong to? I think we have made the shortcut, no? We have made the shortcut. Let me take you back to this one. The shortcut to remember is 0, 128, 192. Means 192 is your class C network, isn't it? So 192 is denoting the class C. So what is done? Class C means the net ID is what and the host ID is what? Can you tell me? What is the normal class C network's host and net? The normal is net ID is 24 bits and host ID is 8 bits. But what have we done? We have just changed this combination. And what are we doing here is we are simply doing something, and that is called CIDR, classless interdomain routing. We have used a suffix like maybe 18. And this means 18 bits will be used for the net ID and the last 14 bits will be used for the host ID. Now, normal is 24 plus 8, but we have used the suffix through which the normal 24 plus 8 will be turned into 18 plus 14. And you can see for yourself, definitely 18 means and 14 means still substantial availability of more host IDs. Are you getting it? And this concept should be clear in order to understand the subnetting later. May I move ahead? And you can see the suffix increases the flexibility regarding which bit which represents the net ID and which bits are going to represent the host ID. Dear children, any questions? Now moving to, if there is no confusion, now let me recap. We have talked about IPv4, the points that are what is IPv4 IPv4 features, 32 bits separated by dots, dictionary value, an example that it cannot go beyond 255. And now we are moving to, then we talked about class ABC network that was dealing with IPv4, and then we talked about the net ID and the host ID and classless interdomain routing or CIDR. Now we are moving to IPv6 addressing, and here we can see it has been developed to reduce the problem that we encountered with IPv4. And this system uses 128-bit addressing, first thing, which allows for more complex addressing structures. And next thing is address is broken into 16-bit chunks. Second point about this. And thirdly, it adopts the hexadecimal notation. This is the third point. And then the fourth point is just an example. Along with the separation of the values by a colon sign rather than a dot. So when you talk about the IPv4, the values are separated by a dot, and here in IPv6, they are separated by a colon. I think it's very much clear. The differences are very clear to you. And when I say hex, again, a hint that I'm giving you, if they give you a question that says that a value is not a hex value, so you will treat this as an invalid value. IPv6 only is composed of hex values, means it will be 0 to 9 and A to F, not going beyond F. Now, why it has been designed to reduce the problem that you had earlier with the problems has, and I can see IPv6 has benefits over IPv4. It has no need for network and address translation, removes the risk of private IP address collisions, has built-in authentication, allows for more efficient routing. So these are certain points that you need to know in order to talk about the benefits of IPv6 as compared to IPv4. Another important thing in this regard is your zero compression. Now here we can see what is it. It's very simple. You may have seen that if IPv6 may have a few values which are composed of all zeros. Like they may be, as you can see here, for example, this just example is mentioned for your benefit. You can see all zeros. So just to reduce the way you write, it can be written as, you can see 900B is here, the way it was in the example. 3E4A is here, AE41 is here. But when it is 0000, then it is replaced by your dots. That is what is called zero compression. As you, by the way, I hope that we remember the term compression. Compression means reducing the size. So here the reduction is the reduction of the zeros. And it is done only once. Remember, one key thing is if your address is composed, are you clear about this? Zero compression means if your address is composed of zeros like this, then you remove the zeros and you replace them with the colon sign. The two sets of colons, the colon sign are going to represent that in this place there were zeros that are replaced by the colon sign. Are you clear? And remember one important thing, zero compression is applied only once to an IPv6 address. Otherwise, it would be impossible to know where the zeros were compressed. And that is an example quoted for your reference. Just an example, you can see here, A055, F2FF, F2F2. Then there's one set of zeros and another set of zeros. You can see here. So in this case, any one set will be compressed. Either it will be compression on this one, as you can see here. Compression of this one means after A055, F2F2, it's four, like two colons are placed here. And then you can see FF11 and then the rest next zeros are there. Or you can see for yourself that the first set of zeros is present as it is, and the last set that is before DD04 is compressed. So just be clear, compression, zero compression is done only once. It is not possible to apply zero compression more than once, because then it will not be able to know where the compression, where the zeros were. This will make the thing a little ambiguous. So this is what main thing is, zero compression. What is it? It is applied in IPv6, not in IPv4. Please be clear. And it is applied only once in your IPv6. It is not possible to have the zero compression applied more than once in your IPv6. Now moving to subnetting, once again discussed here in detail, and be very, very attentive. CIDR is actually based on subnetting. When we talked about bifurcating or dividing 24 plus 8 combination into our own as 18 plus 14, that was an example of subnetting. And the same is continued here in this example also. Now, what is it? CIDR is usually actually based on subnetting, and the two are similar in many ways. Subnetting divides a LAN into two or more smaller networks. So what is the advantage? You can see it is going to result in making your work more manageable because you are dividing your LAN into two or more smaller networks, and that is done for a reason. I'll talk about that right now. This helps reduce the network traffic and can also hide the complexity of the overall network. This is why we perform this subnetting. Be very clear. This is what is the this is going to help reducing the network traffic and will also hide the complexity of the overall network. Recall that IP addressing using IPv4 is made up of net ID and host ID, as we talked about earlier. And then now just moving to the example, all the devices in the on the university network will be associated with the net ID and the host ID. Values are going to be from this to this. Just be, again, one more thing, be cautious. Although we said 0 till 255, but in reality, all zeros and all ones are not the norms because they are forbidden. Host IDs containing all zeros and all ones are forbidden. It means that we are left with not 256 but 254. And this is what something you should be very clear about. Reason, all zeros or all ones are forbidden. That's why we are left with starting the values from 0000001 till this value. But then you can see this is going to make your system look like this, make your network look like this. Assume this is the university network. And university network has different departments like admin and finance, humanities, math, science, arts, engineering, computing, or business. So in reality, what will happen? You can see the host IDs might be like no the moment a person has joined in maybe any one department. So in this concept, what will happen? Every new entrant or every new computer attached will be assigned an IP based on the availability. It will not be determining that which department does it belong to. But like you can see here, they have given you an example. For example, in the admin department, might have host IDs of 1, 8, 2, 40, 35, 67, 88, 134, and so on, with similar speeds with similar spreads for the other 7 departments. So this is going to, now if you see for this one, you will not be able to know that which department do they belong to. But with subnetting, what is the advantage? Are you clear about this? I mean, a moment a new computer is added to any department, the person's computer will be assigned an IP address without having the idea that which department does he belong to, without subnetting. But with subnetting, what will happen? You just be very clear. It will be beneficial to organize the net IDs and host IDs, so the network was a lot less complex in nature. With subnetting, the host ID is split as follows. Now you can see here, this is what the subnetting is happening. Now I'm just making a different color coding to make you understand a little better that what will happen with this. The first 3 bits are net IDs and the last 5 bits are the host IDs. You can see. Just color coding this for you to benefit. Just remember CIDR. Whenever we are studying this, always remember CIDR to make the concept clear that this is subnetting. We are bifurcating, dividing our normal into something else. Any problem till now? Have you understood? The normal 8 bits we have bifurcated into 000 for 3 bits for net ID, and the last 5 bits are now reserved for the host IDs. And you have total of 8 departments, and you can see total 8 departments, 1, 2, 3, 4, 5, 6, 7, 8. So in order to handle 8 departments, what are we doing is we are bifurcating it into 3 bits for the net ID and the last 5 bits are for the host IDs. Any questions? You can see the advantage. The net ID was 192.200.20 dot was there. What we have done, we have just divided this into this manner. You can see now we have assigned dot 0 to admin and finance. We have assigned humanities dot 1. We have assigned dot 2 to math. In this manner, every single department is assigned a net ID, and advantage will be if a new computer is becoming a part of any, it will be assigned a host ID based on which department does he belong to. Has he been added to? Are you getting it? Just be a little clear. Now, if, for example, I entered the university and I became a part of computing, before the subnetting was done, I will be assigned the available ID. I will be assigned the available IP address. Are you getting it? Ji children, are you clear about this? Just be a little clear, and inshallah you'll be very through with this one. Without subnetting, what is happening? The moment I joined the department, I joined the university, I'll be assigned an ID based on the availability. But if its subnetting is being done, then I will become a part of 192.200.20.6. So even the person who is managing the network, the person who is managing who is working as a network administrator will know that computing means it is starting from dot six. And I will be then given a host ID based on the availability. And here we can see the host IDs is still good enough. If you just convert it into its equivalent value, that means it will be from 1 to, can you convert it? Just recall your 1, 2, 4, 8, 16, 32. Yes, 1, 2, 4, 8, 16. What will it be? 16 plus 8 plus 4 plus 2. Won't children be very quick? Yes, it will be. You can see for yourself, it will be 1 to 30 is good enough. So if a person is entering any particular department, so he will be assigned the IP address based on the on his placement. So have you all understood? See, earlier the number of computers connected will remain the same, but the advantage will be now through this subnetting, I will be able to join my particular department's network. How many of you have understood this concept, have recalled this concept? Not understood, basically, we are simply revising. We already have studied all the concepts. So you can see here, if any person has joined the humanities department, so he will be getting 192.200.20.1, and then he will be assigned the host ID based on the availability. Like again, 1 to 30, 1 to 30. So every single department will have 1 to 30, and the host IDs are going to be from 1 to 30, and the available net IDs are based on the values like this. So this is going to make it more manageable. This is going to reduce the complexity, and the administrator can know how to handle the network also. So you can see for yourself. The same thing is shown here in the form of table, and the same thing is shown here in the form of the network also. Are you all clear about this? And this is the bifurcation further to make you understand. Earlier it was 192.200.20 dot. Now it is bifurcated into 3 bits and 5 bits. 3 bits are denoting the red color means it is the net ID, and the last 5 bits are denoting the host ID. Now instead of 8, see, now this is the CIDR, not bifurcation. Earlier it was 24 and 8. Now what are we doing? We are making it 24 plus more 3 bits, and then we are going further with 5 bits only. We have divided 8 bits into 3 plus 5. Are you clear with this or not? Normal was 8 bits. We have bifurcated into 3 plus 5. Ye children, are you clear? Just let me show it to you so you can understand. Ye children, are you all clear about this? Just let me know with a yes or a no. Normal was your 8 bits. For your host ID, we have bifurcated into 3 plus 5. The same we did for earlier for 18 plus 14, same thing we have done here, making it more manageable, making it more easier for the administrator to handle. Gee, children, are we all clear about this? Okay, thank you very much for the prompt answer. Thank you very much for those who have just said this, and this is a continuity of the same. You can just go through this. The same explanation is given with other examples to make you understand for the other departments, and this is it. This is it. The net ID and the host ID, and then you will be able to understand a little, like again, this is all in not colored, but still you can see for yourself that it is basically 192.200.20.03. 03 is denoting the net ID, and the host ID is your just simple all zeros here, or maybe something like that. So this is how you can simply make it more manageable. You can understand a little better. Just by looking at this, you can see that which department does it belong to. Now, this is the science department, or maybe the arts department, or maybe the humanities department, or maybe the computing department. No questions? Okay, thank you very much for this reply that you are all clear about this. And then again, you can see class A, 16 million possible addresses. Class B is 1 million possible addresses. Class C is nearly 65,600 possible addresses. And they've talked about private IP and public IP, which we already have talked about. So I think this is very clear. Our internal values only allow for entirely separate set of addresses within a network, allow access to the network without taking up a public IP address space. However, devices using these private IP addresses cannot be reached by the internet users. They are only available within a particular environment, within a particular company, within a particular network, not accessible by the outside people. Public IPs are the one allocated by the user's ISP to identify the same. See, it's the same as we talked about. In the earlier session, we have already talked about the same thing. Now, another important topic that can come in the paper is URL or Uniform Resource Locator. Simply, the web browsers have a URL or an address that is denoting their identity. And remember one thing, the URL is not understood by the computer, so it is converted into its equivalent IP by the DNS server. Now, moving to this one, web browsers are software that allow the users to access and display the web pages on the screens. This is what the definition of web browser will be. They interpret HTML sent from the websites and display the results. Web browsers use URLs, which are there to access the websites, and they're represented by a set of 4 numbers such as 109.108.158.1. Now, what is it composed of? You need to know the parts of the URL, and that is the first thing is your protocol. The second thing is your website address. The third thing is the path, and fourthly, it is the file name. And in some places, we treat path and the file name to be same. Website address is bifurcated or divided into domain host, which is www, domain name, which is the name of the website, the type of the domain, which is .com, .org, .net, or whatever, and something like a country code that is denoted by .uk or .pk or .whatever. Another example of this is mentioned here, and that can come in the paper that you are asked to divide to tell that which part is meaning what. Another important topic of this chapter is DNS, as I talked about. Remember, something that if I type the URL, it is not understood by the computer. So computer needs the IP address. So for this, what happens? First of all, my computer, which wants to access a particular website, will consult the DNS server. The moment I type the URL, it is consulting the DNS server 1. If found, find returned. Otherwise, it will consult DNS server 2. And the DNS server 2 will return the IP address to server 1. It will now include it in its own database, and the equivalent IP will be returned to the computer, and only then a two-way communication between the computer and the DNS server is going to help out. And again, the same thing is explained here, the use of the arrow from this to the DNS server 1. DNS server 1 is sending the request to DNS server 2, and DNS server 2 is sending back the URL's equivalent IP to DNS server 1, and then the return of the IP address back to the computer, and then a two-way communication will begin. This is what can come in the paper, like again, a probability. I mean, you would never know. And scripting is actually something that is very much similar to although it is not to be understood like rote learned by you people or whatever, but still just a little bit of scripting that basically it is not a part of the syllabus anymore. JavaScript and other stuff is here just for your learning. Otherwise, that is the end. So any questions before we finish our lesson for today? Okay, Jazakallah khair Kasira for being a part of the learning journey. Hope that you have understood each and everything. Subscribe the channel, share with your friends and family, so they all are going to benefit from it. Allah Hafiz, and stay tuned for more videos that will be uploaded inshallah very soon. May Allah bless you, may Allah help you. Allah Hafiz from my end.